Hi, my name is Brian Freeset. I'm the team lead and the OBC lead, and we are the senior design team for CySat, working with M2I.
I'm Kyle Mueller. I'm the UHF lead.
I'm Xiangzhu Yan. I'm the ADCS subsystem lead of this project.
I'm Chase Kirchner. I'm the ground station lead.
My name is Ryan Hansen, and I am the software-defined radio lead.
What are you trying to build or design?
What we're making is a satellite, and it's going to be a CubeSat. It's about this big. It's 3 units wide, and we're building it with pre-made components from EnduroSat and things like that. We're also going to be building our own circuit designs and putting it all together with our own software for our OBC or onboard computer. And with that, we're going to interface with all these different devices and learn something new.
So who are you building this satellite for?
This project is a project that was handed off to us by the CySat team, which is a subcomponent of the M2I team here at Iowa State. It's a group sponsored by Boeing. It influences students to go into space exploration and technical fields.
So for all of our viewers back home, what is the most interesting part of this project for the average citizen?
Yeah, I think that's really interesting just because people will be able to analyze our actual scientific findings. And then also, I think that it'll just inspire people to actually think that like they can work on a actual space related project if we as students are doing it ourselves.
So what are some of the technical challenges with completing a mission like this?
Yeah, so this is a extremely extensive project just because there's a lot of different pieces that really go into it through actually implementing and testing, handing it off to NASA. So we're really dealing with expensive components where there isn't a lot of actual room for error. So we really need to be careful when actually trying to build this system.
So will this satellite just be floating around in space forever?
No, so when we launch it, it's going to be dropped from the ISS, and with this drop, it's going to continuously go around the Earth until it's going to keep just like slowly decaying orbit until it comes down to Earth atmosphere, and then it'll burn up on re-entry, so it won't hurt anyone on the way down either.
So what benefits will this project have?
We're going to be setting up these software systems for future reference for Iowa State's launches. Going forward, they're going to want to do more launches, and they're going to do new and exciting stuff with the code we have a baseline for. They're going to expand on it, and they're going to reuse it where they can, and we're just going to be the baseline for it.
Are there any sorts of rules or regulations that this project needs to adhere to?
Yes, so since this project is going to outer space, there are several regulations in place by NASA as well as other programs that basically condition how this project has to work. There are various rules for the CubeSat program that were set in place by Stanford University as well as other universities that we have to follow. NASA themselves have regulations about the CubeSat and how it behaves when it's near the International Space Station. There's various other regulations about RF interference and other things with ground satellites and other electronic devices. So there's quite a few regulations that we have to adhere to and make sure that we are.
So who is helping to fund this project?
Make to Innovate M2I directs all funds needed to complete this project. Where Make to Innovate is a program in the Department of Aerospace Engineering at Iowa State University. And over the project's lifespan, more than $20,000 have been donated from groups such as NASA, M2I, and ISGC.
So when is the launch going to be? Are we going to be able to watch it?
Yeah, this satellite is planned to be launched into the space as a part of the payload for Northrop Grumman rocket, currently scheduled for launch in mid to the end of 2020. And of course, you can watch it on the live stream.